Hello everyone. This printer next to me is the Elegoo Neptune 3 Max. It's the big new 3D printer from Elegoo. It's a 420 by 420 by 500mm build volume, and it's a FDM style 3D printer. I've been using it for the past few weeks, building all sorts of various projects, some vase modes, some solid things, some sculptures, and this lamp behind me. It's been quite enjoyable to use, and it's a really good price machine at around 470 money units, but it definitely is not perfect. So let me show you what I do like and don't like about this machine so that you're well informed, just in case you want to buy one. There'll be links down below, and this video is sponsored by Vector 3D, so check out my shop at the links down below too. Normally we call fun size things small things, you know, they're like maybe smaller versions of larger things, but I would call this a very fun 3D printer to use just because of the absolutely enormous things you can print. There's something just weird and wonderful about coming into the 3D printing room in the morning and seeing an absolutely huge print just sitting on the bed ready to be harvested. There can be some really big challenges that come along with larger printers, and that's where a lot of the negative things come from, but there are some great things that they've done as well. Firstly, the bed. Despite being very, very large, I found it very easy to get it level enough and to print all the way across it for very large prints. It uses a combination of fixed bed posts, some bed level adjustment kind of wheel knob things, and an automatic probe. Now, generally you want to set the bed and forget it and then just use the automatic probe at the start of each print, and that should get you the best results. That's pretty much what I've done. There is one trick though, which I'd recommend, and that's to have a thicker first layer than your other layers. Especially if you're sticking with the 0.4mm nozzle. Small nozzles make big first layers a bit difficult. The bigger the nozzle, the bigger the first layer, the much easier they are to kind of stick down and have consistent. The next thing that can be a problem with big printers is wibbly wobbliness. Now this printer is not wibbly wobbly. It's very robust, very sturdy, very stiff. That's thanks to a kind of pretty rigid extrusion frame, but also this bracing which goes up the rear, and that kind of prevents any fore-aft tilt, as you've got quite a large accelerating mass being the bed. Even up to the very highest parts of the 3D prints, like this cat and the larger vases, there's no real issues with wobbliness or gantry movement or anything like that. The extruder design is very similar to the one I found on the Creality Ender 3 S1 Pro. They don't really look it from the outside, but the internal extruder hotend design is very, very similar. And the extruder and hotend on this printer is the same as the other two smaller versions in the range. That small assembly is identical, as far as I can tell. The extruder design itself is the dual gear type, so you've got gears pushing the filament from both sides. There's a small tension adjustment in the side which you need an Allen key to access, and a large lever on the top. It might sound like a really small thing, but that lever is really good. It's nice and wide, so you can press it with it's a lot of force, but it's low pressure because it's spread over a large area. It's just a really good lever design. I like it a lot, even though it's like the most basic thing ever. While the extruder design has been quite good for printing, whilst capturing some B-roll for this video, I did notice there's quite a lot of this powder, which seems to be as a result of the brass gear rubbing on the Delrin one, but it's all inside the extruder, so that's not so great. Hopefully Elegoo can find a fix for this. While there's quite a lot to like about this machine, there's also quite a lot, unfortunately, that I don't like. The hotend system on this printer is a kind of standard design. So they've used the same hotend through all their range of sizes for this printer, and it's very much standard, kind of standard flow rate, 10-ish millimeters cubed per second, maybe the 8 to 12 range, a brass 0.4mm nozzle. And you might think, well, that's the standard, what's wrong with that? But it's really not optimal for this size and type of machine. One of the most important parameters in low print times is not actually print speed, but instead acceleration. For a given size motor and belt kind of stuff, a larger mass will result in lower capability of acceleration. So you're going to be basically limited by how fast you can accelerate the bed. What I would rather see is a high flow hotend, a high flow nozzle, and a very large nozzle orifice, like 0.8 or 1mm, and that allows you to still have low acceleration from your bed because it's a system limit, but you can still have a fast overall print time because your flow rates just go huge because of the really large nozzle orifice. And because of that large flow rate, you don't have to move the hotend as fast in order to still have a quick print. The next thing I don't like about the Hotend design is the heat break. In this case, it's a PTFE lined Hotend, which means the PTFE tube, which is like the feed tube for the filament, goes all the way down and touches the nozzle. The fact that they've advertised this printer as being able to print ABS with A PTFE lined Hotend, B, absolutely no enclosure, and C, an absolutely enormous build volume that if you're trying to print large ABS things, you're never going to succeed on a print this size. It's just not going to happen. Very, very small things, you might get away with it, but you've still got a PTFE lined Hotend, which can't really go hot enough without causing degradation of the PTFE, which causes nasty fumes, breakdown of the PTFE, high chances of clogging, all this kind of bad stuff. You cannot really print ABS on this machine, in my opinion. The next thing where I feel like they've overlooked the size of the printer when making a design decision is the spool holder. Now, it's off the top of the screen here because the printer is absolutely enormous, but it's basically designed in line with the other size machines and holds a 1 kilogram spool. For example, this block here, it took quite a little time to print. It's not really very solid. As you can see, it's nowhere near the size of the printer. 1.5 kilos. 1 kilogram spool holder is just not big enough for a printer of this size. It works, yes. Is it ideal? Absolutely not. You can just about do large vases. The next massive oversight, which you can see on screen, is here. This cable that joins the Hotend and extruder to the kind of rest of the printer droops down below the Hotend. It drags across any print that you do, it drags across the bed, it catches on stuff, all sorts of problems. Depending on what you're printing, it can not get stuck, which is great. But if you're doing something with like prints over like different areas and it's got like spires, this will just catch on your print and just break it, pull it off the bed, whatever. It's just not good design. There needs to be much better cable management to prevent this thing drooping onto the print. The other thing I didn't like is that they've used red Loctite to attach the heat break to the heat block. Why is it there? I've absolutely no idea. As far as I can tell, it's bad manufacturing tolerance that would cause it to be loose or cause plastic to leak. So you fill it with red Loctite and it solves your problem. At the end of the day, if all you're going to do is print with it, you're not going to notice. The last thing I really have a problem with is print profiles. They're basically non-existent. The ones that are there are not really even for this printer. The bed size was not even set correctly. So you put it in the middle of the bed and then it prints in the corner because it's a different size bed. Just print profile, print optimization in slicing profiles needs to be a lot better. Now, this is not just really focused at Elegoo. This is basically all the kind of low-end-ish printers at the moment. They're all coming out without basically any print profiles. It's very difficult for me to even test the performance of a machine, how well it can print without a profile. So I then need to make a profile, which is fine, I can do that. But then what am I testing? Am I testing how good I am at making a profile, or am I testing how well it can print? From a user perspective though, which is of course much more important, you want to be able to purchase a machine, assemble the very quick thing that you need to do, and then print with it. You typically, unless you're very enthusiastic, don't want to spend tens of hours tuning a specific material with a specific nozzle size and layer height, and then go, oh, now I need to do a print with a 1mm nozzle. Oh, we've got to start again, do all the profiles again. It's just a lot of work to invest into a printer before you really even get using it. In my opinion, pretty much every printer should come with print profiles for a variety of basic materials, PLA, PTG, TPU if your printer can do it, and some sort of like nozzle range, 0.4, 0.6, 0.8, and then that's kind of enough. It's a very good start, and it really needs to be done at the factory and not by each individual user who just gets a printer. My personal recommendations, if you're looking at getting one of these machines, is to A, get a really big nozzle. Well, really big, at least 0.6, probably 0.8, and maybe maybe 1mm if you want to do like really fat layers, like this or like this print. The second thing you should do is get a heat break that's not PTFE lined. So typically now these are bimetallic, they're kind of a copper and stainless steel or something, sometimes titanium. You don't have to spend loads on one. So yes, a bimetallic or stainless steel or some other non-PTFE heat break. The final recommendation I would make is consider looking into Clipper. Clipper is a 3D printer firmware that uses a single board computer like a Raspberry Pi to control the control board which controls the machine. What you can do with that is something called input shaping. Input shaping is a method of managing acceleration. It basically allows you to print faster or with higher acceleration than you would otherwise be able to do. By having Clipper, that also gives you the opportunity for a web interface and like network uploads and other stuff like that, lots of monitoring, all those kind of cool things. So as well as potentially printing faster, you have a whole load of usability improvements as well. So in conclusion, yes, you can print a lot with this machine. You can print large and you'll probably have a lot of fun like I did, but it's definitely not perfect. This thing will catch on your prints. The nozzle needs to be bigger and the spool holder needs to be bigger. When you have a big build volume, you need the big things to go along with it. Although it is a pretty good price point, so you'll probably be wanting to get one anyway. There'll be links down below in case you do. Thanks very much for watching, and I'll see you in the next one.